the aerial density should not be more than 40 kg per meter square. So we are having both the solution that with the boron carbide, we are having the ADA in the range of 38 to 39 kg per meter square. Again, the boron carbide is having three types: 2.5 density, 2.6 density, and 2.9 density using the TiB2. Silicon carbide, we are able to match the aerial density of 40 kg per meter square by changing the backing composite. With the silicon carbide, the advantage is that the weight, we are just meeting the 40 kg per meter square, but the volume of the silicon carbide based hybrid hard panel is smaller as compared to the boron carbide. So the fitting of the bulletproof jacket will be more effective if the thickness of the panel is less. And the same thing is applicable for the soft armor panel part, because if we are using a lot of foam and all those things, so the comfort level of the soldier will go down. So in future, the aim is not only the weight, but also to the volume optimization. And this is the basic schematic you all know, so I'm just not going to explain this slide. And these are the different types of ceramic material. In fact, Colonel Saab has also told. Only one thing I will just specify, that there are the three routes by which we can make the ceramic material. Hot pressing, the hot press boron carbide is made by the hot pressing. We are just taking the boron carbide powder into the graphite die, and then we are applying the pressure, temperature, and the vacuum. Here, since the boron carbide is a type of covalent bonding, so the sintering of the boron carbide is always done at a higher temperature, high pressure. So this is the reason that the hot press boron carbide is developed in form of a tile solution. And the tile solution, if we are integrating it, the integration of the tile solution is extremely important, because there should be no gap. And the integration also, when we are using the backing composite, and this adhesive type will also be important, because after shot number 1, 2, and 3, the bullet is stopped to a specified area, but the stress wave, the shock wave which has been generated into the entire structure of the plate, so the debonding happens even to the tiles which seems to be okay. So because the backing, the joining of the boron carbide tile with the backing composite is extremely important, otherwise the tile solution will have in its own problem after the shot number 3rd and 4th. And we are having the one process which is called the reaction bonding. In the reaction bonding process, we are making the green body in form of using slurry, and that slurry is having the different types of binders. So that slurry is dried, then we are having a dried green body, and then with the infiltration of the free silicon, and that's reacted with the carbon, all the porosity in the reaction bonded is converted to the silicon carbide. But with the reaction bonded process, the free silicon, if that is left, that is become a big challenge, because if the bullet is hit to the area where the free silicon is more, the free silicon hardness is quite low as compared to the hardness of the bullet. So the quality control in terms of for the reaction bonded process is always a challenge. And now we are having the pressureless sintering process. Now we are adding the different type of the sintering additive like the TiB2 and the ZrB2, where these addition will lower the temperature of the sintering. Like in hot press boron carbide, we are having the sintering temperature of 2200 degrees centigrade. Here the pressure sintering, we are sintering temperature of 1900 degrees centigrade. And with the addition of the TiB2 and the other ingredients, we are increasing the fracture toughness. And what the Colonel Saab has told, that the monolithic plate, we have worked a lot of this thing on the part of the monolithic plate. Now we are having both the solution. The monolithic plate, if we are adding the TiB2 and some other ingredients, so that increases the fracture toughness. And you can see there are the total 6 types of the ceramic that are being used currently for making the hard armor plate of the bulletproof jacket. So hot press boron carbide, reaction bonded boron carbide, pressure sintered boron carbide, hot press silicon carbide, reaction bonded silicon carbide, and silicon nitride bonded silicon carbide. So we have studied all the 6 grades of the ceramic, and we have found that the hot press boron carbide is the best, but that is in the form of tile. But we are having the 2 more good solution which can meet the weight requirement of the BIS standard, and also this can be converted to the form of the monolithic plate. Again, the research on the monolithic plate has been done to increase the fracture toughness, because what the Colonel Saab has told, if the 3 shots has been fired in the close vicinity of the 51 millimeter, so there are the 2 options to increase the fracture toughness, one, the addition of the TiBu2, and so that increases the fracture toughness from 3.5 MPa root meter to approximately 4.5 MPa root meter. And also if we are increasing the thickness of the ceramic, so the formation of the circumferential crack will be less, so the probability of stopping the close vicinity shot in the inter-shot distance of 51 millimeter will be good enough. So now with the R&D done, the type of the ingredients and the type of the understanding of the circumferential crack, now we are having both the solution and even the tile solution and the monolithic plate solution are able to stop the 51 millimeter in inter-shot distance of both the level 5 and level 6 of the BIS. These are some of the property components of all the 6 types of the ceramic, and as I told that the backing composite also very important. With the ceramic, the backing composite of the ceramic is of ultramolecular weight polyethylene. This is the lightest material, being the density of 0.97 gram per cc. So there are the different grades of the ultramolecular weight polyethylene. One of the studies shows that the polyurethane matrix-based ultramolecular weight polyethylene will be the best for using the backing composite with the ceramic. And some of the basic concept you know all, because I will not go into the detail. And some type of the shock loading, what we have studied, that the multiple shot, one of the important data for the audience is that if we have to stop the 3 rounds of the level 6, that is the sniper round, so we can develop a hard armor panel with aerial density 34 to 35 kg per meter square. And if we have to stop the 6 shots of the this sniper round, so that AD goes to 38 to 40 kg per meter square, because if the number of shots on the ceramic are more, so we have to increase the thickness of the ceramic in order to accommodate the circumferential crack generated upon the hits of the bullet. We have studied the different type of the simulation for the helmet. We have made all the 3 types of the helmet, like stopping the 9 into 19 mm bullet. It is already by using the services, and we have also made the helmet we can stop the AK-47, MSC and the hard steel core bullet. But the only thing is that the traumatic brain injury effect is also underway. Unless and until we are having a complete study that the stopping of the bullet with the backface nature less than 30 millimeter for the helmet is not an issue with the hard steel core bullet. But the only thing is that the type of the shock wave that will be transmitted. So a lot of study has been done by DRDO, but some more study will be required to convert those traumatic brain injury into a quantity where we can say that the value of this type of the backface nature will lead to such amount of the traumatic brain injury to the head. So these are all the study what we did, and this is the study for the monolithic plate of the ceramic plate. Again, by the designing of the ingredients of the ceramic, even the monolithic plate is also able to stop the 6 rounds of the sniper within the close vicinity shot of the 51 to 55 millimeter. This study shows that we did some of the study using the shot per shot X-ray in the monolithic plate, and we have mapped the formation of the cracks after each shot, and then we have optimized the thickness and the ingredient of the ceramic solution, that what should be the most optimum thickness and what the quantity of the ingredients of the TiBu2 that should be added in order to maintain the quality of that monolithic ceramic plate, where we can stop the 6 rounds in the close vicinity of 51 to 55 millimeter. And we are also working on the blast protection suit, sir, so that provide the protection against the anti-personnel mine blast. So thank you, sir. Thank you very much.
Thank you, Dr. Pariyar. Now I call upon Dr. P. Ramasubba Reddy, who will be delivering a talk on latest development in materials for armor protection. He is from DMRL, Hyderabad.
Good evening, sir. So I'm the last presentation. So my co-speakers are most of the part in armor research has already covered, so I will not take much time. I'll be touch upon whatever is not covered. So because the armor concept is, be it personal or vehicle armor, concept is same, but however the threat levels are different, so we have to adopt slightly different approach. So I will go into the details, what we are doing at DMRL. So before starting that, I would like to express my sincere thanks to the CAPS and management, the authorities who have organizers of this symposium for giving me this opportunity to present DMRL work on this occasion. And since morning, we are seeing that DMRL name has come many times because DMRL is the main material research laboratory addressing the material requirement for aerospace, naval, and land systems. So in my presentation, I will be talking about the material development for armor vehicles. So this is the approach we follow at DMRL for material development for armor applications. We start from the threads, the requirement, understanding the threads. This basically we get from the QRs. And after understanding this one, we go to the materials. Whether they are developing from the alloys or modifying the existing materials. Then in this area stage, we involve the academia because here the TRL will be 1 to 3 levels. Then from there, we move on to the designs. Because to make them as a useful things, we have to design using the guided by modeling simulation and scale testing methods. And after the designs are frozen, we move on to the modules because we have to integrate them, develop some process engineering like the weldability, machinability, and also in the case of ceramics, profile cutting. So all these process engineering related things we establish at this level with the help of industries because here it will go to the TRL higher level. And finally, the components will be validated by using the suitable test protocols. And parallelly, we establish the test facilities also because which are very important for, we have seen in the morning also, any product or technology we develop, we have to see that the testing is done properly and it is reliability is there. So this is our framework for developing the armor materials. So this is the conventional AFE design the paradigm. It is there since decades. So the tanks are designed these 3 parameters like iron triangle, but the basically firepower, protection, and mobility. And the traditionally all these Indian AFEs are using the balanced approach, following all the 3 things. But however, now we have seen the ongoing conflicts. So the tanks are not only tanks, any ground system hardly has any place to hide because there is a lot of improvement in the electronic systems, drones. So there is difficult to survive with the land systems. Therefore, there is a need to change this triangle and we have to add many things because in the beginning the tanks are considered as the king of the war. So but today is the threat is there for the tanks. If we are unable to take the tanks in the outside because if it is exposed, there is a hit. So to counter that one, so we need to adopt the different approach. So in addition to these 3 parameters like the firepower, mobility, and protection, we have to add 2 more elements, that is EM suit and situational awareness. Because if the tanks are protected from the top attack, the drones or any